getting charge out of water droplets. Discovery: when water droplets spontaneously jump away from superhydrophobic surfaces during condensation, they can gain electric charge in the process. Superhydrophobic surfaces, the extreme water-repelling property. Discovery by MIT researchers last year. Recently the team demonstrated that this process can generate small amounts of electricity that might be used to power electronic devices. The experimental chamber setup. How it works. System is based on Miljakovic and Watt's 2013 findings, in attempting to develop an improved heat transfer surface to be used as a condenser. That droplets on a superhydrophobic surface convert surface energy to kinetic energy as they merge to form larger droplets. This sometimes causes the droplets to spontaneously jump away, enhancing heat transfer by 30% relative to other techniques. They later found that in that process, the jumping droplets gain a small electric charge. This process is now used to generate power, simply by giving the second plate a hydrophilic surface. As the droplets jump, they carry charge from one plate to the other. If the two plates are connected through an external circuit, that charge difference can be harnessed to provide power. False color time-lapse images captured via high-speed imaging show the droplet jumping colored green from a superhydrophobic copper oxide fin to a hydrophilic copper fin colored orange. Generating power. In initial testing, the amount of power produced was just 15 picowatts per square centimeter of metal plate. But researchers says the process could easily be tuned to achieve at least 1 microwatt per square centimeter. Such output would be comparable to that of other systems that have been proposed for harvesting waste heat, vibrations, or other sources of ambient energy, and represents an amount that could be sufficient to provide useful power for electronic devices in some remote locations. For example, at 1 microwatt per square centimeter, the Q measuring about 50 centimeters on a side, about the size of a typical camping cooler, could be sufficient to fully charge a cell phone in about 12 hours. While that may seem slow, people in remote areas may have few alternatives. Constraints. Because the process relies on condensation, it requires a humid environment, as well as a source of temperatures colder than the surrounding air, such as a cave or river. Approach. This discovery can lead to devices to charge cell phones or other electronics using just the humidity in the air. And as a side benefit, the system could also produce clean water. Thank you.